Hi, my name is Cooper Alford, and this is my session 6 video for my portfolio optimizer for the high net worth client. First, I want to talk about my stock selection. So I decided to pick Microsoft, Johnson & Johnson, and JP Morgan as my three stocks. I wanted a diversified portfolio, did some research with AI, and found that these three different sectors, Microsoft is tech, Johnson & Johnson is healthcare, and JP Morgan each have their own diversification backgrounds of why they don't add up that much. And you'll see that in the correlation matrix later. Microsoft is mostly our growth one. That's going to, tech will be mostly volatile, but also have some big returns. So we'll have that as our big money grabber. Johnson & Johnson is super crisis resistant. Healthcare doesn't really go down during crises. In COVID, it actually went up. And JP Morgan is our financial services, which is kind of our value stock. So first off, we have all our imports, very basic. Then we have the first step of our first module is data collection and pre-processing. I had a lot of problems with this session and data collection. Something about why finance and Google Colab really just do not want to work with each other sometimes. And I get this error, says adjusted close when I try to download multiple tickers. And usually what it says is adjusted close, you should have your ticker instead of ADJ for the code running. Something like that. I had to rerun it a couple times, and sometimes it just does not want to work, and I have to restart from the beginning. But it's very robust in how it gets its data, so it takes a lot of different methods in order to get it, in order to run it correctly. But it's been running real smoothly. So it gets our date range. Tries downloading individual, which is usually how it works. If you try to download them all together, it just malfunctions. Gets their ticker, individual stocks, downloads all the data. Then we go bulk download just in case with proper column handling, just so it runs a lot more properly and whatnot. Usually that does not work, and then some sample data as a fallback, but it does not sample. It is our checking. Double checking. Yes, that is definitely the real variance correlation. Sorry, should have checked that before. But yeah, that's our sample data that would have came up. That is not what's down there, and it creates our covariance matrix that runs all the normal things. So here's basically getting our returns and all that. So it gets our daily returns for the data, our expected returns from our 252 trading days from our yearly calculator, and then our covariance matrix, our correlation matrix, and our annual volatilities. Which is all important information for calculating the efficient frontier and everything later on. And that'll display our basic summary statistics of each individual stock, which is super helpful for making sure that everything is adding up correctly. And then return our five basic things. Return. Then we have our optimization set up. So this is when it gets into our weights and starts calculating our portfolios to run through our efficient frontier, which is just slowly coming up. Return variance volatility and our Sharpe ratio, basic things, volatility and a negative Sharpe ratio in case that happens. Then it gets to our efficient frontier, which will calculate each individual one based on the covariance matrix and the maximum expected return we can get based on our risk. We use 0.04, which is taken from the current treasury bill. We have our constraints and bounds, our range of current targets, our minimax, and our results will all be stored. It'll be much more easy to explain once I get to the graph, which I know pretty well from former finance classes. Adding a constraint for our target return to make sure it works, our initial guess, and our minimizing our volatility to actually get that curve going. Then we find our optimal portfolios, the minimum variance and maximum Sharpe ratio portfolios, which the two we want to focus on, and that'll make it both these again will make a lot more sense when we get to the graph and whatnot. But it gets to our minimum variance result, which minimizes our volatility, initial guess, and our negative Sharpe ratio. Then we get to our performance metrics, which is basically going over those portfolios and their individual weights, returns, volatility, and Sharpe ratio for each. Then we plot our efficient frontier, which is the big one, which really explains and how we can show to our high value or high net worth client what our math is doing and what how to visualize the minimum risk or the maximum return to risk Sharpe ratio. individual stocks, optimal portfolios. And then we get to our actual selection where it picks based on the 100, or I think it's either 100 or 1,000 portfolios that it generates, which is the best um, based on the spreadsheet that it generates. A custom portfolio, target return, target risk, return success, and our validation and documentation. So it validates everything, checks all our weights, negative weights, extreme concentrations, calculations, general validation, and then our report that prints through our two main portfolios and our custom portfolio if we provide and our risk considerations and recommendations, which are pre-generated because of the 3 stocks that I have. I mean, we could change that to something else if we wanted to, if we had an input or whatever. And then our main execution just runs through all the lines up all the code and all the different modules, which keeps it nice and organized. See step 1, collect data, calculate efficient frontier, optimal portfolios, create the portfolios, visualization, validation, and generate a report. Finally, the run function. How much time do I have? Oh, tons of time. So let's run through this code. Uh-oh. Okay, pause. Okay, part 2. My internet has been awful. It does not want to run in front of me. It just gave me the green check mark and ran it, so I will show you what it's like when you run through the code. So we have our 100% 3-stock portfolio optimizer has been run for our Microsoft, J&G, and JPM stocks. So it collects the data in step 1 over the last 5 years individually, 12,054 data points collected. Downloads for each individual one and success, all stocks successfully collected successfully, all dates. Then we run our statistical analysis, gets our return statistics and volatility and Sharpe ratio. As you can see here, we got Microsoft is our bigger expected return with a bigger volatility, kind of similar to JP Morgan, but similar Sharpe ratio, whereas J&G is a very low return, but also a much lower volatility, so it has a much lower Sharpe ratio, but it's more of our anchor defensive stock. Then we have our correlation matrix, seeing that these are all lined up to 1, because when you're in correlation with yourself, that's just perfect correlation. That doesn't really matter, but here we have J&J and Microsoft have a pretty low correlation of 0.1, and the other two have a correlation of 2.8 and 2.4. So all below 0.5 and pretty low correlated, which will help a lot with the portfolio matrix and creating diversification. Since it's so much below 1, it'll lower our portfolio volatility much lower than they would individually. As you can see, they all have pretty high volatility, and I mean, Sharpe ratio of 1 for these two are pretty good, but that one's not so great. Step 4 finds our optimal portfolios, creates the custom one for a target return of 10%, and shows our efficient frontier. So this is what I was talking about. This from what I can see is textbook of what a efficient frontier should look like. It gives our expected return on this y-axis, while it gives our volatility on this x-axis. Basically, the more volatile you'll go, once you get to a certain, so it starts out here, J&G, basically perfectly J&G. If you only invest in the J&G, it's going to give you that super minimum expected return, because that's at the bottom of what it is, whereas the maximum return is JP Morgan. If you invest 100% into that versus 100% into that, then as you invest less into that, you get a little less volatility, and a little more return, until I'm guessing minimum variance portfolio is probably 0% J&G or close to it. So this is the minimum volatility you can get with the maximum expected return, or it's basically just the minimum variance volatility, just the farthest left on this curve, because this would be more right, this would be more right. Whereas you have the maximum Sharpe ratio, which is return to risk. So you can see there's a drop off in our diminishing gains, our diminishing returns as we go up, and that's the maximum we can get. Whereas we invest all in the JP Morgan and just max out returns, we'd have a very high volatility. Or we just max out volatility with Microsoft, which is not on the efficient frontier. But these two are. So if you can 100% either of those, and they would still line up on the code. You don't want to invest 100% in Microsoft, is what this is telling us pretty much. So yeah, minimum, maximum Sharpe. Then we get this step 7, our validation. So it calculates that our validation pass, our return was good, our volatility was good, and our final return report for our high net worth client. They got 3 stocks, and this is our big one. So minimum variance portfolio, the red diamond on our chart, basically gave us an expected return of 13.39% and volatility of 14.44. Sharp ratio of 0.6, which is solid, definitely solid, but as we'll see in a minute, that's not as great as it could be. And our allocation would be 20% to Microsoft, 60% to JNG, which is the one down here. So it's obviously a lot more closer to these two, which makes sense. And 16% to JPM, which is the max Sharp ratio. Then we have our max Sharp ratio portfolio, which is an expected return of 25.97%, much higher. So this is optimally risk adjusted. And our minimum variance is basically just for conservative investors. So if this guy's conservative, maybe look at this. More optimal, like this is what we want. That's a great Sharp ratio of 25%. Volatility is kind of high at 20%, definitely on the upper side, but it's solid. And that's 0% in the JNG. So we could probably change out this portfolio and switch a different stock in if we were to go for optimized Sharp ratio and probably find some better numbers and whatnot. And 64% in JP Morgan, which makes sense. It's a big value stock, has a lot of growth. Same with Microsoft. So this one is our safety stock is out the window once we want to maximize returns. Then we have our custom target portfolio where we expect a return of 10%. That would basically just give us a let's see, 10% is like right around here. So I basically would give us a volatility of 15. Doesn't make 100% sense, but that's mostly J&G, and that's really just not an optimal target portfolio. So you can see this is how it mathematically proves that these two are the two that you want to be searching for in terms of like what you want to talk to your client about. If they want to be more conservative, they want to be right here. Whereas if they want to max out, they want to be right here. Or if they want to be somewhere in between, they should pick a point on this line and pick how much return works for them and how much risk works for them, or either or. Most clients want a maximum sharp portfolio, so should probably give it that unless they're really conservative. And yeah,